Hello.
Good evening, sir.
Yeah, good evening. Have you tried the exercises for Loney?
Yes, sir.
What are the doubts?
1 second. In exercise 21, uh, question number 35.
Uh, 35
Question num
is 4 or 2 theta, that one.
Yes, sir.
Okay. Question is solve the equation 4 cot 2 theta is equal to cot square theta minus tan square theta. Okay. I don't want to
Yes.
work with cot and all, so I would try to convert everything to tan. So I can write this side as 4 by tan 2 theta. This side as 1 by tan square theta minus tan square theta. Why am I converting to tan? Because I have formulas for general solution of tan, right?
Yes, sir.
I don't remember formulas for general solution of cot and all. I only know sine, cos, and tan, right?
Yes, sir.
So this now I'll simplify a little bit. 4 by 2 tan theta, 1 minus tan square theta, that is the expansion of tan 2 theta, is equal to 1 minus tan power 4 theta by tan square theta, right?
Yes, sir.
You cannot cancel factors because you don't know how it will be. The best way is to not cancel factors so that you don't lose out on some roots. Like for example,
Yes.
I will not cancel 1 minus tan square theta directly because it could be that this is 0. Right?
Yes, sir.
You understand what I'm saying?
Yes, sir. I
1
just cut
minus,
them. So,
so if you cut them, you'll miss out on some answers because you have forgotten to take the case that tan square theta is 1.
yes,
That
sir.
will also solve both sides. So if you cancel stuff, then you will miss out on things. So what we'll do is not cancel, bring everything on one side. Minus 1 minus tan power 4 theta by tan square theta equal to 0. Here this cancels with a 2. There is a tan theta here, tan square theta here. So common denominator will be tan square theta. And on top you get a 2 tan theta, 1 minus tan square theta minus 1 minus tan power 4 theta, right?
Yes, sir.
So now I can take common factor 1 minus tan square theta outside. 1 minus tan square theta is a factor. Inside I get 2 tan theta minus 1 plus tan square theta. So minus 1 minus tan square theta, right?
Yes, sir.
This is what I am getting, and this is clearly negative of 1 plus tan theta whole square, right?
Yes, sir.
So we get this negative 1 plus tan theta whole square. Whole thing is divided by tan square theta equal to 0. So now the way in which it can be 0 is if the numerator is 0. Numerator can be 0 if tan square theta is 1 or if tan theta is minus 1.
Yes.
Tan theta is minus 1 or tan square theta is 1, which gives us tan theta could be plus minus 1. So ultimately you have two cases, tan theta could be minus 1 or tan theta could be plus 1, right?
Yes, sir. Yes.
So the answer will be n pi plus minus pi by 4.
2 n pi, no?
What is the formula for tan theta?
Theta equal to. Oh, yes.
Formula has 2n pi or n pi.
N pi, n pi.
If tan theta is 1, you get n pi plus pi by 4. And if tan theta is minus 1, you get n pi minus pi by
Oh,
4.
yes, yes.
Do you understand how this is coming?
Yes, sir.
What is the next doubt?
Question number 38.
Okay, solve the equation tan theta plus tan 2 theta is equal to root 3. Okay,
It is plus root 3 tan theta tan 2 theta.
okay,
Yes, sir.
so it is obvious that we can take this on the other side. If you take it on the other side, you will get tan theta plus tan 2 theta is equal to root 3, 1 minus tan theta tan 2. And then if you
Okay,
divide
sir.
it, you can write tan theta plus tan 2 theta by 1 minus tan theta tan 2 theta is equal to root 3, right?
Yes, sir.
Why is this good? Because this is formula for tan 3 theta.
Yes,
Theta plus 2 theta expansion would be this only, right?
yes, sir.
This is tan pi by 3 is tan 3 theta, and you'll get 3 theta is equal to n pi plus pi by 3. So 3 theta is equal to n pi by 3 plus pi by 9. And you also have to make sure that this part is not 0, should not be 0.
Yes, sir.
Why? Because we are dividing.
Yes, sir.
You are dividing, it cannot be 0. So you need to check that tan theta into tan 2 theta should not be 1, right?
Yes, sir.
So if you check the answers here, if you take n is equal to 0, you're getting pi by 9. If you take n is 1, you're getting pi by 3 plus pi by 9. N is 2, you get 2 pi by 3 plus pi by 9. And n is 3, you get pi plus pi by 9. At these values, tan theta times tan 2 theta, most likely it will not be 1. So tan of pi by 9 times tan of 2 pi by 9. Pi by 9 is like 20 degrees, 2 pi by 9 is 40 degrees. Both of them values are less than 1, so product is cannot be 1, right?
Yes, sir. Yes.
I'm just checking to make sure that none of my answers is giving this. If it is becoming 0, then I cannot do this division. That
Yes.
answer has to be excluded.
Yes, sir.
But none of this will become 0 because, for
Yes, the
example, for
product is less than. Yes.
this product is less than 1. To take a bigger angle, this might be bigger than 1. Or actually, when you take pi by 3 plus pi by 9, it's like 80 degrees. But if the other one is 160 degrees, so the value will be negative, tan 80 into tan 160.
Yes, sir.
Because this is negative, this is positive. So answer is negative, so it cannot be 1.
Yes, sir.
None of these will give you an answer of this factor will not be 0, so therefore this step is fine. Therefore the answer will be this.
Uh,
You have to check these things because you cannot randomly do operations on equations without being careful whether you are missing some roots or whether you are getting some extra roots, things like that.
okay, sir.
You cannot divide by a quantity which could be 0, right?
Yes, sir.
What is the next doubt?
Uh, Question number 41. Like I tried like sine pi cos theta is equal to sine pi by 2 minus pi sine theta. But again, I got this sine theta and cos theta. Can't able to eliminate the thing.
What do you have to prove here?
Like cos theta plus minus pi by 4 is equal to 1 upon 2 root 2.
1 by 2 root.
Yes,
So we have to use this to try to prove this. So
yes,
how do I use it? I will say sine of, you can convert both to sine or both to cos. We'll try with cos here. This is cos pi by 2 minus pi cos theta is equal to cos pi sin theta, right?
yes, sir.
What is the general solution for this case? Cos is equal to cos.
Pi by 2 minus pi cos theta equal to 2n pi plus minus pi sin theta. Yes,
You get this equation right now. We can obviously cancel pi everywhere. We'll get 1 by 2 minus cos theta is equal to 2n plus minus sine theta. So from there, we are getting cos theta plus minus sine theta is equal to 1 by 2 minus 2n, right?
yes, sir.
Now, what do I have to prove here? See what I have to prove. I have to prove this thing. If you try to expand it, what will come? Cos theta, cos pi by 4 is 1 by root 2 and plus minus. So minus plus sine. So 1 by root 2 sine theta, right?
Yes, sir.
Expansion of this is this. You can say 1 by root 2 common. It is cos theta minus plus sine theta, right?
Yes, sir.
I'm already getting this. So I'll just take 1 by root 2, right? Both sides.
Yes,
Is equal to, we are getting 1 by 2 root 2 minus root 2n, right?
yes, sir.
Okay. Then this side I can write as, this side can be written as, take the 1 by root 2 inside and it becomes cos of theta plus minus pi by 4, right?
Yes, sir.
Take the 1 by root 2 inside and write it as cos pi by 4 and sin pi by 4. Obviously, this is going to become these.
Yes, sir.
We're getting it is equal to 1 by 2 root 2 minus root 2n, right?
Yes, sir.
Now what we have to think about is, okay, when we wrote the general solution, n could be any integer, right?
Yes, sir.
So what are the integers that is possible here? That is what we have to think here. N is 0. If n was 0, obviously you'll get the thing that we want, right?
Yes, sir.
If n is 1, let's see what happens. You get 1 by root 2 minus root 2, right? So this is becoming 1 minus 2 root 2 into root 2. So this is 4 by
4,
2
yeah.
root 2. So this is clearly minus 3 by 2 root 2. But you should realize that this is less than minus 1. Because 2 root 2 value is 2.828 and all. This is
Uh,
minus 3 by 2 root 2. So this is minus 1 point something, right?
yes, sir.
Is it possible for cos to give a value which is less than minus 1?
No, 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 sir.
So n is equal to 1 is not working, right?
Yes, sir.
If you take n is equal to 2, it will become more negative.
Yes, sir.
So any higher value of n will obviously all of them will not work because it will become more and more negative, right?
Yes.
We have to check n is equal to minus 1 now. Take minus 1, you get 1 by 2 root 2 plus root 2. That is becoming 5 by 2 root 2, right?
Yes, sir.
Again, it is bigger than plus 1.
Uh, it can't be bigger than plus 1. Yes.
So n is equal to minus 1 doesn't work. Minus 2 will also not work. All the other numbers won't work. Only number that works is n is 0.
Okay, sir.
In general, this is the expression that we are getting, but n cannot be any integer other than 0, right?
Yes, sir.
If n cannot be anything other than 0, then this is proof.
Yes, sir.
We are getting the solution till here. This is obvious stuff. Then you have to realize here that nothing other than 0 can work. You put 1 or -1, it is not going to work.
Uh, yes, sir.
Do you understand what is happening?
Yes, sir. Understood. Like we can eliminate in the previous step, like cos theta plus minus sin theta equal to 1 by 2 minus 2n. So we can eliminate n from there also now. Like,
It's the same thing.
uh, yeah.
Whether you eliminate it at the last step or at the previous step. But it is more difficult to fix. What is the maximum and minimum value of this?
Maximum value.
It is more difficult to imagine what is the maximum and minimum value of this, or whether it is easier to do with when it is like this.
Yes, understood.
What have you understood?
Like cos theta plus minus sin theta, getting the maximum value and minimum value is like
More
more difficult.
annoying.
Yes, sir. Like where cos theta plus minus pi by 4, we know the range of cos theta, like it should be in the range of -1 to +1.
Here it has to be between -√2 to +√2. The logic is the same. Anytime you have a cos theta plus b sin theta, you can always take 1 by root over a square plus b square inside and multiply outside by root over a square plus b square. What is the benefit of doing this? Now, a by this is always less than 1, first of all. B by this is also less than 1.
Uh, yes, sir.
So if something is less than 1, both the quantities are less than 1, then they can be written as cos or sine of something.
Yes, sir.
And you can see that this square plus this square is adding up to 1. Square of a by root over a square plus b square plus square of b by root over a square plus b square adds up to 1.
Yes.
So since it adds up to 1, we can write it as cos alpha sine alpha, right?
Yes, sir.
For some same angle alpha, which is unknown right now, but it must be some constant angle. Why
Yes.
are we able to write it as cos alpha and sine alpha? Because the values are less than 1. We can't directly write this as cos alpha and sine alpha because we don't know whether a is less than 1 or not.
Yes, sir.
Do you understand what I'm saying?
Yes, sir. Understood.
If I write this as cos alpha sine alpha, I can write the whole thing as cos of theta minus alpha. And outside there is a root a square plus b square, right? Do you understand what I'm doing?
Yes, sir.
Instead, you could also have written this as sine alpha and this as cos alpha. You could have written the whole thing as root a square plus b square sine of theta plus
Now
alpha.
sin theta plus alpha. Yes.
The point is the same because they are, when you square it and add it, it becomes 1. So both can be written as sine alpha, cos alpha, sine alpha, whatever. And then you can use the sine a plus b or cos a plus b formula to write it like this or like this. But our point of doing it like this was basically to be able to say what is the maximum and minimum value of this expression. Now that it is written like this, obviously it can go from minus root over a square plus b square to plus root over a square plus b square. Because cos of thing can be from -1 to 1.
Like if they will introduce the tan, then we can't use that procedure, no?
But
If they will introduce the tan, like then they will tell the maximum and minimum value. Oh no, with no the maximum value of tan.
what is the maximum value of tan?
Like plus infinite to minus infinite.
So what is the point of doing that? That is, there is no, can't do anything with tan. Tan you can go up to whatever number you want.
Oh yes, sir, yes.
Do you understand what I'm telling you right now? Focus your attention on what I'm saying.
Yes, sir, understood.
How am I getting the maximum minimum value of this as minus root 2 and plus root?
Like we have proved now, like a square means the maximum value of it, uh, any form like a cos theta plus b sin theta is equal to plus minus root under a square plus b square. And here it is a equal to 1 and b equal to also b is also 1. So yes,
But if
root
you
under
didn't know this, then you would not be able to do this. And then it will be difficult to figure out what will be the n.
yes, sir.
Right now, because I know this, that's why I can still do it. I can say that n is equal to 1 if you take it is becoming half minus 2 is minus 3 by 2, which is less than minus root.
Yes, sir.
If you take n is equal to minus 1, you'll get a plus 5 by 2, which is greater than plus root. Nothing is going to work other than 0.
Yes, sir.
What is the next doubt?
Um, next out is from exercise 27.
Okay. Which question?
Question number 9. It is a sine a by 2 plus b is equal to b plus c into sine a by 2.
You have to prove this. So, fine. So again, what we will see is standard strategy is get all the trigonometry stuff on one side and all the sides on one side, right?
Okay, sir.
That I have used many times. By now you should know that. You understand what I'm saying?
Yes, sir. I just
And
expand and
if you just expand, then that is not very smart.
yes, sir.
I'm not going to randomly start working on whatever they give me. I will do some clever thing. Like clever thing here is don't work on a mixture of sides and trigonometric ratios. I will work on trigonometric ratios one side and sides
Okay,
on
sir.
one side. And it is very easy now because I can just do RHS. I can simplify by sine rule. By sine rule, I know B by sine B is 2R. So B is 2R sine B. Plus C is 2R sine C. By A is 2R sine A. So what is RHS?
Sine b plus sine c. Yes.
If you now do the things 2 sine, this is becoming B plus C by 2 cos of B minus C by 2 divided by 2 sine A by 2 cos A by 2, right?
Yes, sir.
Clearly, this part is 90 minus A by 2. So this is cos A by 2, which gets cancelled from here.
Yes.
We are getting cos of B by 2 minus C by 2 divided by sine A by 2. And now I can write this B by 2 minus C by 2. I know that A by 2 plus B by 2 plus C by 2 is 90. So what is b by 2 minus c by 2? So I can write that as, okay, e by,
Like we can substitute the value of c by 2 as 90 minus a by 2 plus b by 2.
hmm, we can put that here. It will become cos of b by 2 minus 90 plus a by 2 plus b by 2, right?
Yes,
This is becoming cos of b plus a by 2 minus 90, right?
yes, sir.
We know that
Now
cos of minus theta is same as cos theta.
cos theta. Yes,
So I can replace the sign here and write it as cos of 90 minus b plus a by 2, right?
yes, sir.
Which is sine of b plus a by 2. Denominator was anyway coming. Now we have got the numerator also.
Yes.
That is the proof of ninth one. Which is the next doubt?
Like 10 question. Question number 10.
Prove that a square plus b square sine of,
Like here I tried like I I tried to expand the denominator using sin c plus d formula, but didn't get.
first of all, you need to know this identity. What is sine of a plus b into sine of a minus b? You can prove that it is equal to sine square a minus sine square b. You can also do this other identity, cos of a plus b into cos of a minus b. You can prove that it is cos square a minus sine square b. First of all, prove this. Right now, prove this yourself and then try to think of how you will use this here.
Okay, sir.
Do you understand what I'm saying?
Yes, sir.
Try to prove this one, and then try to use that identity to prove this one. You have 5 minutes. Try it in 5 minutes.
Okay, sir.
Okay, I'll be back. 5 minutes. Are you getting something for 1 and 2?
Yes, proved one.
Just expand it, multiply it, you should be able to get it, right?
Yes.
Similarly, 2 also you can do, right?
Mm, yes.
Right now we'll use this identity here. So how will we use it? We'll focus our attention on this first term. So I have a square. So I can write a square as a and a sine b minus c by sine b plus sine c, right? And this
Yes.
inside a I can write as 2r sine of a, right?
Yes.
So notice that sine of a in a triangle is sine of b plus c, right?
Yes.
So what will happen here? 2r sine of b plus c multiplied by sine of b minus c, right? Correct?
Yes.
So if I use the identity now, this identity, what will happen? It will become sine square b minus sine square c on top,
Oh, yes.
divided
Now
by
a
sine b minus sine c, sine b
now
plus
a
sine
plus
c.
yes sin b plus sin b minus sin.
You get 2ar sine b minus sine c, right?
Yes.
Okay. So similarly, you will get 2br. Other terms will be sine c minus sine a, right? And you will get
Yes.
2cr sine a minus sine b.
Yes.
So you'll take 2r common. What we will get is one big bracket, right?
Yes.
So take 2r common. We'll get one big bracket. A times sine b minus sine c plus b times sine c minus sine a plus c times sine a minus sine b, right?
Yes.
And it is now obvious if you group it, you will get a sine b minus b sine a plus b sine c minus c sine b plus c sine a minus a sine c after grouping.
Yes.
What is a sine b minus b sine?
A sin b minus b sin a.
What is a sine b minus b sine triangle? Obviously, it is zero root sine rule.
Oh, yes, yes,
Don't know sine rule.
yes, and no, yes,
Can
yes,
you see that you can cross multiply and get equal equal?
yes, right.
This part is zero, this part is zero, this part is zero. So the answer is zero.
Yes,
What are the steps involved? We took one a outside, one a we converted to 2r sine a. 2r sine a became 2r sine b plus c. Sine b plus c sine b minus c became sine square b minus sine square c. That cancelled, sine b plus sine c became sine b minus sine c. Then you just took 2r common and you got this expression, right?
yes, yes.
Finally, you break it apart and you get groups where sine rule tells us that this is 0, this is 0, this is 0.
Like using the sin a plus b into sin a minus b. It was a critical, although, but
It can
how
be
to
done by
think?
other methods also. This is the best method.
Oh, yes. Like I tried sin c plus sin d in the denominator, but it was lengthy.
Uh, it will be lengthy. By other methods, it will be lengthy. This is the best method, which is fast. You have to know these identities.
Yes,
You have to write these down. This is important. That's why I'm showing you right. The methods will be longer.
yes.
What is the next doubt?
Question number 30.
Tell the question once.
A square minus B square plus C square in the bracket into tan B is equal to A square plus B square minus C square in the bracket tan C.
Okay. It is quite easy if you just focus on LHS.
Like
Have you seen? Uh-huh.
I tried to convert in cos B form because we can write tan B in like sin B by cos B. So if I divide with 2, if I multiply and divide with 2AC by, yes sir, 2AC,
This
then
bracket is simply 2AC cos B.
yes sir,
So what is this? 2AC sin B.
yes sir.
What is this bracket? By cosine rule.
It is 2AB cos C.
So
Oh,
this part is becoming 2AB sin C. You can see 2A is anyway common. C sin B is B sin C.
like, and we can do in this way, like we have to prove now.
You think अभी proof नहीं हुआ है?
uh,
नहीं हुआ है क्या अभी proof?
मतलब दोनों तरीके से कर सकते हैं क्या, मतलब दोनों को
मतलब तुम
एक्सपेंड।
एक ही तरीके से करोगे, यहाँ C sin B को B sin C लिख सकते हो क्या? इसको तुम क्या ऐसे लिख सकते हो? 2AC sin B is 2AB sin C. Is C sin B equal to B sin C? ये पता है कि नहीं पता है?
हाँ हाँ, ये तो यस सर।
पता है ये। तो ये इस स्टेप से इस स्टेप जाया जा सकता है अभी।
हाँ यस सर।
तो राइट हैंड साइड में क्या आ रहा है?
तो यस सर।
कुछ भी इसमें मुश्किल नहीं है, ऑब्वियस है, सिंपल सा है। बस साइन रूल यूज करना है, कोसाइन रूल फर्स्ट स्टेप में यूज करना है।
यस
समझ में आ रहा है कुछ?
यस सर।
फर्स्ट स्टेप में कोसाइन रूल, सेकंड स्टेप में साइन रूल। The idea will come if you do both sides and see, okay, this side I'm getting this side I'm getting this. Obviously, this is equal to this. जब फाइनल प्रूफ लिखोगे तो you will do on one side and get to this. You will not do this side while showing it. कुछ समझ में आ रहा है कि नहीं आ रहा समझ?
यस सर, आ गया।
ऐसे भी प्रूफ वाले क्वेश्चंस तो आते हैं नहीं. You need to know how to do it. Doesn't matter how you write it. Anyway, you can write it by hiding all this and showing that this has come like this. And now I can write this as 2AB cos C into tan C. And now I can write this as A square plus B square minus C square into tan C.
यस सर।
What is the next one?
I tried only question till question 15.
You need to try all the rest of the questions also. Nothing here has to be not tried. You understand what I'm saying?
यस सर।
This whole exercise 27 as much as possible you have to do, because the more you do, the better your situation will be. And
Yes,
also,
sir.
chapter 15, have you started reading the remaining parts?
Like,
I told you to read the x circle derivations, right?
yes, sir.
Did you read the derivations x circle?
No, sir.
No? क्या होगा?
वो भाई भूल गया था।
भूलोगे तो नहीं चलेगा, फिर भूल जाओगे तो कैसे चलेगा? ट्रिग्नोमेट्री फिर भूल ही जाओगे सबको। भूलना नहीं है, होमवर्क जो है सो करना है।
यस सर।
You need to do the x circle derivations and start the first exercise of chapter 15 after you have done the remaining questions of chapter 12 exercise.
ओके सर।
Next class will be about remaining questions in chapter 12 and x circle derivations, what you have understood from there, those things.
ओके सर।
Okay, fine. That's all for now then.
ओके, थैंक यू
Bye.
सर।